Hello class, today we're going to be looking at 6.6 comparing graphs. So what we're going to be doing is we're going to be putting two different scenarios and we're going to be putting them under the same graph as you can see down here. And then we're going to compare the two graphs. So what we're going to be looking for example is Brittany is looking to buy pizza for dinner and she's going to be calling two different places. We're going to go over those scenarios now. So first place she calls is Pizza R Us and they tell her that a large pizza is $6 plus 50 cents per topping. So for A, we need to determine an equation for the cost of pizza from Pizzas R Us. And we're going to explain what each variable represents. So we're going to say let C represent the cost because we want to know how much is Brittany going to pay for her pizzas. And we see that it costs per topping as an addition. So we're going to let T equal the number of toppings. So our equation is going to look like C, which is our cost, is going to equal 0.5, so that's 50 cents, times the number of toppings that we have, plus $6 because there's a flat rate that we have to pay. So now we need to create a table of values for our cost of pizza. So this is just an easy way for us to see these things before we put a graph down. So if she were to buy a pizza with 0 toppings, it would cost her $6. We added 1 topping. We would take 1 and add it to our T, so 0.5 times 1 plus 6 gives us $6.50. We're going to keep going with that, so 0.5 times 2 plus $6 will give us $7. So for 3 toppings, it'll cost us $7.50. For 4 toppings, it'll cost us $8. Now we're going to continue on up to 6 toppings, and we're going to see from there. So our table of value ends there, but we are going to continue on with our graph. So now we need to graph the relationship between cost and number of toppings. So our number of toppings is the one that does not change our price. We get to choose that. So that's our independent variable. And then our cost will change depending on the number of toppings. So it's our dependent variable. So right off the bat, we see with 0 toppings, it costs us $6. So we need to put our first point right there. And then as you can see with our scale, we've skipped over every other line to give us a little bit more spacing. So we're just going to continue on with these numbers. So $6.50, $7, $7.50, $8, and this one right there would be $8.50, and then we see $9. So we can get a line of best fit and we can run that right through and it'll continue on. So what kind of variation is this and how do you know? Well, we know it's a partial variation because it doesn't go through the line of origin, right? We see that it starts at 6. We know it's a partial right off the bat. So now Brittany's going to go ahead and she's going to call Pizza by the Top. And they tell her that they have a special going where the pizza cost is based on $1.50 per topping. Okay, so we could again, if we wanted to create another thing here, just like this, another table of values, and include those on there. So 0 toppings would cost us $0. That there's not really a pizza for that, so they're going to say that we have to have at least 1, I'm sure. So 0 would be $0. And then we can follow it up $1.50 every time. So we got $1.50, then we've got $3, then $4.50, then $6, then we have $7.50, and then we get it to $9, and it would continue on. So we can get another line of best fit running straight through there along each of the points and continuing it on. So now you'll notice that on our graph here, we've labeled each of those lines. That's very important for us when we're going to be doing our comparison. So this line here is our Pizza R Us, and this one here is Pizza by the Top. So what kind of variation is this one and how do you know? Well, we know it's a direct variation because it does pass through our origin, which is our 0 and 0. Because it goes there, we know it's a direct variation. At which pizza place would someone get the cheapest pizza they wanted with 3 toppings? So now, because we have them already go both on there, we go along the bottom here and find 3 toppings, and we're going to see which ones are cheaper cost. So we see that Pizza by the Top would cost us $4.50, whereas Pizza R Us would cost us $7.50. So therefore, the cheaper one would be Pizza by the Top. Explain the significance of the point where the 2 lines meet. The point is called the intersection. So we see right here, both places line up right here at this cost right here, which is $9. And we see that that's at 6 toppings. So that's our intersect. So that's where our two lines come together. So now what's the significance is? This is where the pizza's cost the same for the same number of toppings. So if we knew that we were going to get 6 toppings on our pizza, it wouldn't matter where we got it from because the price would be the same. Whereas anything less than that, and it's cheaper for us to get it by pizza by the top, and anything beyond that point is actually going to be cheaper for us to get Pizza R Us. So if we were to get 7, 8, 9, or 10 toppings, it'd be cheaper for us to get it from Pizza R Us. All right, now for your work, you guys are going to go through the practice questions and following the same steps that we have above here on our practice questions.